Welcome back. Today we are going to look at some real-world similarity problems. All right, I would recommend taking a moment to read this problem to yourself before you watch the solution. So we are sitting on the ground and looking up at a tower. Here's the ground. You have a friend take a 4-foot pole and move it away from you until its tip is in your line of sight. So here's the pole. And your line of sight goes like this to the top of the tower. Your friend measures from you to the pole and discovers that it's 4 feet. And the distance from the pole to the tower is 30 feet. Your eyes are 2 feet above the ground, and we want to know how high the TV tower is. Well, we know that's a right angle, we know that's a right angle, we know that's a right angle. All right, so we've got two similar triangles. The one that comes from your line of sight to the pole. We know that the distance to the pole is 4, and because the pole itself is 4 feet and your eyes are 2 feet off the ground, this distance, which is part of this triangle right here, will also be 2 feet. The other triangle that we have comes from your line of sight all the way to the top of the TV tower. And we know that we don't know how tall it is, so we'll call that x. But we do know that the distance from you to the TV tower is this distance 4 and the distance 30. So that matches up with this side of the triangle here and makes it 34. So we'll go ahead and set up a proportion so that we can solve for the tower height. The proportion would be 34 over 4 equals x over 2. Those are the corresponding sides. And then we would get 4x equals 68, x equals 17. So we know that the distance on our triangle is 17, which back on our original picture is this piece right here. So that's 17. But that's not the height of the TV tower, because the TV tower goes from the ground all the way up. So we have to include this little piece right here, which we see is 2 feet. So the tower is 19 feet tall. All right, take a moment, read the second question, and then we'll go over it. In this problem, we're trying to determine the height of a tree. So we'll draw the ground. We'll draw our tree. And we have a friend place a small mirror on the ground. So we'll call that M for mirror, so that you can see the reflection of the top of the tree. Your friend measures you, so we need to draw us. Stick figure person, another leg. And finds that from you to the mirror is 8 feet. And the distance from the mirror to the tree is 28 feet. And your eyes are 5 feet above the ground. And so you're looking down into the mirror and back up to the top of the tree. So we have these two similar triangles right there. There's our angle. We have another angle at M on either side. And we're trying to find the height of the tree. So we can go ahead and set up a proportion. We'll put 8 over 28, those are the two values on the ground, and 5 over x, those are our heights. Cross multiply, and get that x is 17.5. So the tree is 17.5 feet. We don't have to add anything in because we were looking directly at the top of the tree, and we don't have to, so it's going from the tree to the ground. Pause for a moment and read the next question. Okay, so you are standing on the ground, and you're 1.55 meters tall, and have a shadow that's 7 meters long. Your shadow's on the ground. A nearby telephone pole, I'm not even going to pretend that I know how to draw that, has a shadow measuring 10.5 meters. And we want to know what the height of the telephone pole is. And we'll assume that the angle of the sun is the same for both because it would be set at the same time. So we'll set up our proportion. We'll say 1.55 over x equals 7 over 10.5. Cross multiply to get that 7x equals 16.275, and x equals 2.325 meters. So the telephone pole is 3.25. Oh my goodness. Let's try that again. It's 2.325 meters tall. I'll fix that real quickly for you. All right. Let me know if you have any questions.